simplifying radical examples. So the first problem here we've done before, but I just want to refresh your memory because it's going to come into play as we look at the remaining examples here. And once again, just a reminder that what we do is we look at the factors of 48. So I did 4 times 12. You could have picked 6 times 8. You could pick 2 times 24. It doesn't matter which two factors that you pick, but they do have to end up to be 48 when you multiply them. 4 times 12. If we break down 4, it's 2 times 2. If we break down 6, or 12, it's 2 times 6. And then 6 is 2 times 3. And if we carry these down, what we're looking for, because we're dealing with the square root, is we're looking for 2 of the same value to take out 1. 2 of the same value to take out 1. So what we've got here is we had 2 2's. We take out 1 of them. We had another pair of 2 2's. We're going to take another 2 out. But we still have the square root of 3. That's a single. We can't take that out. It might be nice if I wrote down a 2 here. But when we finish this, 2 times 2 is 4 times the square root of 3. Just a little checking mechanism. If you type in the square root of 48, you get a big long decimal in Desmos. If you type in 4 times the square root of 3, you should get the same big long decimal in Desmos, or on a graphing calculator for that matter. Now, when we do problem number 2, which is read the cubed root of 24, it's the same idea here. Only this number here, the 3, which by the way is called an index, means that we're looking for 3 of the same value to take out 1. So when we break down 24, which is 4 times 6, you could have picked 2 times 12, could have picked 3 times 8, but it's 2 times 2 times 2 times 3. This time what we need is we need 3 of the same value to take out 1. So when we finish here, we had 3 2's, so we're going to take out 1 of them. We're done with the 2's, and then we're left with the cube root of 3. Again, you could type that in to Desmos to check. You'll still get big long decimals regardless of, just because it still has a square root in it. So when we look over here on problem number 3, the 4th root of 32, so this time what we're looking for is we're looking for 4 of the same value. 8 times 4 is 32, 16 times 2 is 32. It doesn't matter what you pick in terms of factors, because we're breaking them all down. And what we ended up with is we actually ended up with 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. But we need 4 of the same value to take out 1. So we had 4 2's, we can take out 1, and then we have a single 2 that is left. Now, we've seen the numbers. We can apply variables to the same concept. So when we look at problem number 4, it is the square root of 54. Just going to start with the numbers first of all. Same idea as what we did on problem number 1. 54 is 9 times 6. That's one of the options of multiplying here. 9 is 3 times 3. 6 is 3 times 2. And what we're looking for is we're looking for 2 of the same value because it's square root. So 2 of the same value is 3, and then we've got 3 times 2, which are both singles, so the square root of 54 is 3 square root of 6. But that's not all we have. We've got x's and we've got y's. So it's not fun, but I am going to write them out here for a minute. And then let's see if we can come up with a shortcut for figuring out how to simplify variables. So x to the 5th is x. And what we're looking for is we're looking for 2 of the same to take out 1. Same thing with the y's. 1, 2, 3, 4, 5, 6, 7, 8. And again, we're taking the square root, so we want 2 of the same to take out 1. 2 of the same to take out 1. We want 2 of the same to take out 1. 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 So when we finish this, we've got 3. We had 2 x's, we took out 1. Another set of 2 x's, we took out 1. But we're still left with, and I left some space here for the y's, not enough space. I'm going to erase, but left some space. And then we're left with an x. 2 of the same, take out 1. 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 And so I'm running out of space here, and I don't want to infringe on my space on number 5, but what we end up with in terms of our answer here is going to be 3. X times x is x squared. Y is y to the 4th. And then we've got the square root of x. So I'm going to circle that because that is the square root of 54, x to the 5th, y to the 8th, square rooted. And again, the last thing that we really like to do is write down all of those variables. But if we need to, we need to. It works. It's not fun, but it still works. But let's see if by looking at this next example, which only has variables in it, if we can figure out what the pattern is when it comes to taking roots with variables. So like I said, not fun, but here comes 10 x's. And even worse, 15 y's. And 5 z's. This time, we're looking for 5 of the same to take out 1. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 of the same, take out 1. 5 of the same, take out 1. We were able to take out all the x's. 5 of the same in regards to the y's. Take out 1. 5 of the same. Take out another. 5 of the same. Take out another. So we're left with y. 5 of the same, take out 1. 5 of the same, take out 1. 5 of the same, take out 1. Same thing with the z's. We need 5 of the same to take out 1. So when we do, we've got a z. So when we simplify this problem, we really end up with x squared, y cubed, and z. We don't even have any square root left. Let me circle this because that is the solution there, which better make it a little bit more clear. But there is the solution to the problem. Is there any relationship here that you can recognize? And maybe you want to pause the video before you tell me the answer. Maybe you want to look at this and see if you can determine what the answer is. So what I hope you see now, if you've paused the video and then turned it back on, is that if you take 10 divided by 5, you get 2. 15 divided by 5 is 3. And 5 divided by 5 is 1. I didn't write that exponent of y to the first, because Edmentum does not like you to write the ones. But we divide the exponents by the index. And actually what happens as we move on to problem number 6 is that the remainder is what ends up to be underneath the square root. But once again, when we start these, do the number first. 125 is 25 times 5, which is 5 times 5, and we can carry this down. We are looking for 3 of the same to take out 1, so this is going to be 5. The thing is, for the y's, we have 2 y's, but we need 3 of them to take out 1. I'm going to leave a little space just in case there's a z. Don't forget to write that little 3 in the check mark part of the radical. So y squared is going to remain, but what happens here with the z's? 4 divided by 3 is 1, and then there's 1 left over. And again, there's nothing wrong with doing this. Z, 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 Z. We need 3 of the same to take out 1, and then we have 1 left over. So finally, on 256, it's actually 16 times 16, 4, 4, 4, and 4. And I know that 4s could be broken down into 2 times 2 over and over again, but look, what we need are 4 of the same, and we have 4 of the same. So this is going to be 4 for our 256, and then we'll try it again. We still need 4 of the same. I'm going to leave a little bit of space for an x and a y. 7 divided by 4 is 1. So there's going to be 1x with 3 left over. 14 divided by 4 is 3 with 2 left over. Again, if you don't get that, x, 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 x. 1, 2, 3, 4, 5, 6, 7. 4 of the same. Take out 1. There's the 3 left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 4 of the same. Take out 1. 4 of the same. Take out 1. 4 of the same, take out 1, 2 singles left over.